Hi guys, I'm Gloria. I'm here with Courtney and Jake, and we're going to go over project part one um, over our Netflix stock prediction model.
In order to further understand what going into the prediction model would look like, we wanted to look at what a general stock prediction model would look like using artificial neural networks. And we did this by studying an article by Abhishek Kaur, who basically broke it down by first going into artificial neurons and the neural network structure, basically saying that artificial neurons have an input, they do some sort of function, and then they produce an output. And then a network would just be numbers of neurons progressively changing the inputs into new outputs until you receive the desired output. So the first step in that is using a backpropagation learning algorithm, which the highlights of that are finding minima and maximum of the data and minimizing the error function. The artificial neural network will then use these types of different functions: activation, hidden layers and nodes, data normalization, error calculation, and cross-validation in order to achieve the best prediction model. Here's a little bit more about the hidden layers and how they can actually affect the data. The first picture that you see on the left, the green represents the predicted values while the blue represents the actual values. So looking at these two pictures, the first picture is doing a single hidden layer while the second is doing a second hidden layer. So you can see that the second is a much better prediction of the first and will have more accurate data. These layers do not just continuously get more accurate. It's a very small increment and can be seen almost exponentially. So adding a significant amount more layers wouldn't get too much more accurate than this point. What he then did was take the Nifty Sensex dataset, which unfortunately we were not able to find online. But basically, the inputs were open, low, high, and close prices for the Nifty Sensex, and then the output was the close value. They took 60% of the data to train and then 40% to test. And as you can see in the graph on the right, the RMS errors significantly decreased, and the best results ended up being 96%, and the average result was 88%.
So here is the work center, and the work center is where this project would be used. A stockbroker would make his or her trades, hopefully according to what the output of the neural network was. And so the traditional setting for a stockbroker would be in an office. So this is a cubicle. You've got his desk and chair, keyboard, and at least 3 monitors. And so 3 are seen here. And this was all designed in SolidWorks. And the work center just allowed us to use SolidWorks to do some simulation as well as understand where this project is coming from. And now we'll get into how our neural network will function. We've got 11 inputs, and I'll quickly go over these. First is the quarterly earnings, and this is either a 1 or a 0. So yes, that week the earnings were released, or no. So that's pretty simple. And this here is the ratio of the closing. So it's basically the closing of Friday over the closing of Thursday. So it's if it decreased, it'd be less than 1. If it increased, it'd be more than 1. And the same goes for the ratio of closing Friday, Wednesday, Tuesday, and Monday. And then here we've got change from the max of the week. And so really what that means is it takes the max of all the highs of that week. And I guess if the stockbroker is coming in on a Monday, it's of the previous week. So then it'll divide that maximum value by the closing of Friday. And then this will do the same thing for the minimum of the lows. And the same thing is done 1 week prior for these two and 2 weeks prior. And so really you have data that goes back 3 weeks and just comparing them to the closing of the most recent Friday, and hopefully that'll help you. So all of these inputs go into the neural network, and the output will be some kind of, it'll be a numerical value. So depending on whether the value is above or below 0, it'll be either to buy or sell. And this should actually say buy. Apologies.
All right, so this slide shows our mathematical notation. You have our x inputs, our t targets. This is our training function where we use LM backpropagation. Here it creates a fitting network. These lines of code, you can see that we are allocating 70% of our data to training, 15% to validation, and another 15% to testing. And we're using going back 5 years worth of data. This is where we are training the network, and this is allowing us to test the network. All right, so in conclusion, we have a couple things that we need to do still to be able to finish this project. We have to fine-tune our code and design in MATLAB, and then finish implementing it. And we have to finish doing our final documentation by creating another video and finishing our design. All right, thank you guys for watching.